So, an average football game.
Oh wait, you know what, Eric?
Okay, 70 decibels is 10 times louder than 60 decibels. 80 decibels is 10 times louder
It's
than...
fourth block. I was hoping my mom's class was still in her room because they're like right back there. Like that's
Oh
the.
my gosh, we did.
So
Yes.
Oh wow.
no, if it wasn't fourth block, my
I did
mom would have
damage to my
heard me
vocal cords.
screaming through the wall.
I'm surrounded by crazy people.
And
Oh yes,
again,
the insanity center.
I will always give you this equation. I'm not going to expect you to memorize it.
Sandwich.
So,
Everyone has
the
sandwiches.
Doppler effect basically
Sandwich.
what changes what you hear based upon the direction of the source. So, kind of a simple way to demonstrate this is that I'm going to take this tuning fork, hit it, and then I'm going to swing it around over my head. Okay? So, okay?
That sounds really cool though.
I thought Neil was trying to.
It kind of sounds like a little
was
bit like an
trying to
alien
what?
spaceship.
Okay? So, can you hear a difference
No,
Like you sometimes.
as that goes
sometimes,
around?
but not this time.
So,
Ah,
and again, it's handy if you visualize. Now, from my perspective, I can't tell any difference because I'm at the center of it. So, as basically what's happening is, here's your ear, right? And that tuning fork is emitting these sounds. It's going out like this. So, when it's going towards you, it's compressing those waves, okay? And you're going to hear a higher and higher frequency. As it goes away from you, then it's going away and those sound waves are going to get spread out. So this is why you have two different equations for this. One where you're approaching, and both of them is the original frequency. The only difference is that on one of them you subtract it, and the other one that you add it. So here's a different way to, this was even done on the Big Bang. So I'll get back to this, just give me a second.
It all started with a big bang.
Bulgaria.
Gets it, I'm going as the Doppler effect. If I have to, I can demonstrate. So what time does the costume parade start?
The parade?
Yeah, so the judges can give out the prizes for best costume. You know, most frightening, most authentic, most accurate visualization of the scientific principle.
Oh, Sheldon, I'm sorry, but there aren't going to be any parades or judges or prizes.
This party is just going to suck.
Oh, come on, it's going to be fun, and you all
I thought you said they wouldn't notice.
Go ahead and get the goal.
cute.
That's not.
I got a feeling that one Pixie has with your name on it.
Hi.
Hi.
So we're here for French and we're doing a scavenger hunt. And
Hold on.
We're watching the Big Bang Theory.
Someone's back.
We're watching the Big Bang
then we
Theory.
have to give you
We're
some
studying
cookies.
sound. Leave or I will scream.
You're welcome.
I think everyone's
Enjoy your snacks.
All right.
And enjoy whatever's happening right here.
Insanity.
Ryan?
This is all physics is. It's just watching the Big Bang
Thank
Theory.
you.
Yeah. This is
How do you say thank you in French?
Merci.
Merci. There you go.
mercy.
Mercy.
Mercy on my
Mercy.
soul.
All right.
Mercy, please.
Okay. Anyway, back to our story.
You should have picked Mercy.
It's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer.
Oh, sure, I see it now, the Doppler effect. All right, I got a shower. You guys make yourselves comfortable.
Okay. See? People get it.
Hi.
Hello.
So what are you supposed to be?
Me? I'll give you a hint.
Choo-choo train?
Close.
A brain damaged choo-choo train?
Oh.
sort of learning disability. I think it's very insensitive.
Why don't we just tell people you're a zebra? Why don't you just tell people you're one of the 7 dwarves? Because I'm Frodo. Yes, well, I'm the Doppler effect.
Oh my gosh.
Okay.
No, autoplay. Your worst nightmare.
I love you, autoplay. You can't escape the autoplay.
Oh, it's Neil deGrasse Tyson. He's invading our physics.
No thanks. We're good.
But
Have Neil
Dr.
deGrasse
Tyson.
Have Neil
Is he a
deGrasse Tyson
doctor?
invade your computer
Does he have
today.
a PhD?
Yes.
Yeah, he's doctor. Yeah.
In reality, where Mike Tyson and Neil deGrasse Tyson are the same person.
Uh,
I want Mike Tyson and Neil deGrasse Tyson to sit down.
No, it's Mike deGrasse Tyson.
Mike deGrasse Tyson.
Cameo TV series that has
Mike
both of them on
Tyson.
one episode, and they're related. It's hilarious.
That'd be
Like
hilarious.
Mike Tyson's like, we can stay with my brother, and Neil deGrasse Tyson.
That's like a bad
Neil deGrasse Tyson's like, man, no, you can't come in.
That'd be like the coolest family ever.
One person will bite your ear off, the other person will yell at you about.
And then the third one's the CEO of Tyson Chicken.
That's the one CEO of Kentucky Fried Chicken.
No, Tyson Chicken. It's the brand, it's Tyson.
He bit off like 2 episodes. So what about the other person?
I don't even know. Mike Tyson, he's a character. He gave this speech before a fight, and he was like, you know, I'm Alexander the Great. My defense is impeccable. My offense is ferocious. I want to eat his babies.
Whoa.
whoa.
That went a little too far.
That took a sharp left turn.
That took a sharp left turn into Crazyville.
Yes.
Why not the race route?
This is Crazy Lane.
Crazy Lane.
You go to Scarsville tonight?
Yes, I love you.
Oh, we're gonna play.
Oh no.
We have to play them.
Oh no.
Wait, actually, where are you guys
We're taping.
Oh, no, we're going to.
Okay, thank goodness we're not.
We just both have tournaments on the same
Oh
day.
yeah. That's a little strange. Ow.
Wait, it's at Kate.
Hello, darkness, my old friend.
Yes, that's where we gotta go.
Okay.
Oh, wait, no, we've been.
So, and there's actually, there's variations on this thing. So this is like the simplest one. So this is like, you're standing here, and you're having like the train, the ambulance, the tuning fork, whatever, coming towards you. So all I did was just the math to show you what happened. So this is, you got a frequency of 840, which is that tuning fork that I just did. So if it's approaching, you subtract it. So you got 1 minus 17.8 over 343. And so what you're going to hear is, when it's approaching, you're going to hear a higher frequency of, in this case, of 886. Then when it goes past you, then you're going to drop from all the way down to 798. So when it's going away, you're stretching out that wavelength, which is making the frequency go lower. But when it's approaching, it's like you're crunching these up, and the frequency is getting higher.
It's red shift and blue shift.
Basically. So what happens
It's the
now,
same effect,
where this
just
gets
with
real
light.
complicated, is if, there's variations on this. So in some situations, what you can do is have a situation where you are moving relative to the sound source, okay, which is a different equation. So if I'm in a car and I'm approaching like a siren that's stationary, then when I go past it, it's going to be the same thing. But so when I'm approaching it, then I'm going to hear a higher frequency. When I get past it, that's going to change. So this is where this got horribly complicated. So one of my former students, Michael Staub, got a job with the Jet Propulsion Lab. He went to WSU, got a degree in aeronautical engineering, and got his master's in aerospace. And he works at the Jet Propulsion Lab in Pasadena, California. So if you've ever heard of the Cassini mission, which was very, very, very successful and orbited around Saturn and did the rings and, probed the moons of Saturn and all this good stuff. And they finally, September 15th of 2018, had the end of mission where they crashed the probe into the surface of Saturn. So he was what was known as the mission ace. So he actually sat at the controls and sent the signals to the spacecraft, like to make it crash. Okay, like he was cool because I went out there and was able to sit at the console. And,
So
you know,
he was the one who broke the spaceship then.
well, I mean, but he was part of that. I mean, yeah. So he was a vital. I mean, he would literally monitor that spaceship. That was his job for like a couple of years, was to go into work and monitor the Cassini spacecraft.
Do a lot of your students go into like working with space stuff?
Not a lot. It's kind of I mean, my kids go on to do so many different things. I mean, engineers like.
You said one was on a submarine, right?
Oh yeah, I mean, like, so here's like there's a program now with the Fermi Lab where they're trying to find the nature of neutrinos, and so this is the beauty of me teaching is that. So I got Reed Bowles. He did an internship at Fermi Lab where they're actually producing the neutrinos. And they're sending them to a basically detector, which is going to be in South Dakota. And they've got to build this big, massive detection system there. So I got another one of my former students, Reed Abbott. He's working as an engineer on the construction site building the detector systems for the neutrinos. So I got one former student working where they're producing the neutrinos and studying neutrinos. I got another former student who's actually working on the detector site that's going to be able to detect what's happening with what one student is producing, the other one's building to be able to detect it. So I've kind of got both extremes on that. And so
Oh my God.
the
You're
problem
right.
is that here's the sun, here's the Earth, here's Saturn, okay, and you got the rings of Saturn.
Hilberg.
Not to scale. And you're trying to keep track of what's happening with the Cassini space probe. Well, the Cassini probe is always transmitting radio signals and its information back. So what they would do is they would take advantage of the Doppler effect. And so radio signals get shifted just like sound waves do. And so if the Cassini spacecraft was going away from the monitoring station on Earth, they would see a shift in those radio waves towards the long side of the wavelength. If it was approaching, then they could detect that because the wavelengths are going to be changing, the frequency is going to change. But the math became horribly complicated because, number one, Saturn is moving. You have a moving Cassini spacecraft that's orbiting the rings. You have a spinning Earth that is sometimes approaching Saturn, but then on the other, then when it gets past it, then it's going to be, because of the spin, then the radio signal is going to be going away from it, and the Earth itself is moving through space. So to try and work out that math was horribly complicated to use that Doppler effect. But that was the only way they could really monitor the speed of the Cassini spacecraft, because it isn't like they could watch it and there were like, you know, lasers set up and go, oh, it's going to cross this point here and it's going to cross, okay? That was one of the main things that they had available to them to monitor the location of that spacecraft, was the changing radio signals that was being transmitted back to Earth. Okay, I know you all got to leave, so let me give you your assignment. Oh, now, if this weather forecast holds and it's icy tomorrow morning, remember that it's going to be a low coefficient of friction.
So go fast.
Yeah.
Go fast.
If you do, I swear to God, I never taught you physics.
Oh, we're all doing problems today?
We get disavowed if we die in
Hold on.
an ice-related car crash.
But what if it's the other person's fault, not ours?
Then you get to get out of your car and start shouting. No, if someone crashes into you on ice because they didn't slow down early enough, then you get to get out of your car and start shouting at them about frictional coefficient.
But you have to
and how they're
calculate
stupid.
you have to calculate how specifically loud you're going to shout at them.
Teach them physics.
He just
Exactly.
Okay.
Also, the Doppler effect be like, you're approaching.
You're approaching me.
I don't know what that
Instead of running away, you're coming right to me. I can't shift the frequency without getting closer to you.
Darn it.
Am I
Actually,
yes or no?
shift the
Well,
frequency.
I'll get closer to you or further away from you.
But But
Just raise the pitch.
this ranks Mason joke.
It's called a meme, Mia. Jeez.
I don't know what meme you're
I don't
talking
like
about.
the sign
Like
guy.
he went to see movies. This is like the Cameron.
No,
What?
that's one of the few animes I haven't seen.
You need to see it. It's good.
They're in the middle of Black Butler right now.
In the middle of what now?
Black Butler.
I heard Black Panther. I was like, that's just not bad.
That's not
Yes,
an
it
anime
is.
or a TV show.
It is now.
I told that to like my very redneck friend.
Did you take April?
He was like,
What?
You glanced up when you said my very redneck friend. I was like,
Okay, so couple of things to point out. When you get to problem number 29, it's going to say sound is detected when a sound wave causes the eardrum to vibrate. Typically, the diameter of the eardrum is about 8.4 millimeters in humans. When someone speaks to you, no matter how much energy is delivered in your eardrum per second. So, in this situation, you're talking about the surface area of your eardrum. Okay, so this isn't like a wave that's being transmitted. You're just talking about the area that's receiving this energy. So like on 29, you're just going to use pi r squared because you're finding the surface area of the eardrum, okay? Now, when you get to question number 48, I have to point this out because over the years, this question has created, not controversy, but it's become an issue. So in number 48, you have an osprey's call is a distinct whistle at 2,200 hertz, okay? Everybody knows how to do the math, but everybody flips out and they go, what's an osprey? So what is an osprey?
It's a
bird.
It's a
bird.
bird. It's a bird of prey. It's like a
It
falcon.
catches fish.
Okay?
Or a
I think.
helicopter.
So I have to, well,
No, it's not a hot helicopter,
bird.
Mia.
yeah.
It's a type of
So when you get, so seriously, I've had kids go, they'll read this question and they just get completely hung up on, I don't know what an osprey is. Okay?
Really?
Google it. We have Google.
So that's, let me see.
I'm not smart
No,
enough to
there
use
used to be an AP Chem shirt, or an AP Physics shirt that had an osprey on it because they didn't know what it was. So anyway, so when you get to number 48, that's what the osprey is. So you guys are leaving at what, 2:25?
Yeah.
If you guys want to leave a bit early, if you need to get some more time, that's good. It's just
leave early.
So there's classwork time then?
Well, I was able to add a quote to the list of Burt Camp quotes, so I'd say it's a good day.